Yeah, so as part of the work at Fast Forward, as I said, we dive into emerging technologies in order to understand what could they mean for industry. And we release that work as sort of little books, but most importantly, and that's sort of why I'm talking about it now, we also build fully functioning prototypes to sort of showcase capabilities that new algorithms enable. And I just want to very quickly talk you through two of the prototypes that we have built.
Cool.
So let me share my screen that you can actually have a look. Great. Can you see my screen?
Yep, perfect.
Fantastic. So what you see here is a prototype that's called probabilistic real estate. And if you sort of come to the website, this prototype is public. So if you go to the Fast Forward Labs blogs, you can actually play with it and try it out. There's a description about the prototype itself and how you can sort of read it. I'm not going to go through that now, but if you come to our website, you can see it. So let me close that. So it's basically, this is a prototype that predicts real estate prices for New York City, right? And let me sort of say, gosh, I wish I had 2 million, but let me just pretend I have like 1.5 million. And I want to buy a property for 1.5 million. Where in New York could I actually buy something? So if you look now here in Manhattan, there's sort of these light purple to white areas. White means that there's actually hardly any chance that you could buy property there. So slightly purple here, you can see 41%. And so what is interesting then, let's go to an area that I know quite well. For those of you who are not from New York, my apologies, but I believe there's probably a New York audience. So let's go to Bushwick, which is where I live currently. And you can see that if I had 1.5 million, I could actually buy, like there's a good chance that I could buy property there. But what's going to happen, right? So this is today, 2016. If we go back, we can see that actually a year ago, there would have been many, many more properties within my price range, which is great. So let's go back to today. Now you can see gentrification happening at a rapid speed.
Wow.
2017, only I probably will have to go out to Richwoods, which means that I would have to move to Queens. And then 2018, you can see that even Richwoods is starting to become unaffordable for me and my $1.5 million. This prototype, we hope it's fun to explore. We hope people can relate to it. But what's most important here is it demonstrates the power of a technique called probabilistic programming. And that is a set of tools that make Bayesian inference much more easily accessible. So Bayesian inference is a technique that has been around for a very, very long time. It is based on Bayes' theorem, which, comes from Reverend Bayes, who has long been dead. So it's definitely an old technique, but it's been quite hard to implement. And so most people who've sort of worked with Bayesian inference were academics. I myself, during my time as an academic, actually used a lot of these techniques. But now probabilistic programming, those techniques have become more widely available. And so that is why we covered those techniques in our most recent report, because we believe that now it's time for businesses to actually start using these techniques. What's great about these techniques, instead of just giving you a maximum likelihood estimate, the most likely value of like property and real estate value in this case for New York, it gives you the full distribution. So like what other values might be likely and how likely. And that is something that we can actually see here. So we see the full probability distribution for 2018. If we go back, we sort of see that it is shifting, right? And that there are more properties on the affordable side. So feel free to sort of look it up. If you go to our blog, you can see the release and you can play with it. There's lots to discover. Something else that I wanted to show is our prototype called Brief. And Brief is essentially an order summarization engine. So let me show you how this works. You might be on the New York Times website and you found like a really interesting article about please do not punch the dolphins. And I tend to agree with that statement, don't punch dolphins. But I don't have time, unfortunately, to read that whole article. So what I can do is I can put the link into the prototype that we built. It will take a little while. So just bear with me. Yeah, that's unfortunate that this one did not work. So let me sort of go back and go on one that we have preloaded here. Sometimes the underlying parser can be tricky because we're using a third-party tool. Okay. So this is an older article. The algorithm is still loading. So what you will see that will come up here on the left, the top highlights, are going to be 5 sentences. And those are the sentences that are identified by an algorithm in the article as being the most representative of the content of that particular article. And so if you were to read only those 5 sentences and not the full article, then actually you would get the gist of this article. And the underlying technology that is powering the summarization engine is a recurrent neural network. And I mean, we are all, let me click on another one, we're all quite familiar. Here we can see it. So here we have sentences on the side, and then we have the article itself. And it sort of highlights the sentences that are most informative about that article. The ones, if you have very little time, that you really need to read in order to get the gist of the article. And so underlying is a recurrent neural network. We've all been very excited about deep learning and neural nets and sort of the new capabilities that they unlock. And so this is one of them. And this is a recurrent neural network because those tend to be very good for analyzing text data. Convolutional neural networks typically are good for image data. And that is actually a prototype that we built prior to this one, which I'm not going to show today, but please do go to pictograph.us and you can try it out yourself.
All right.
So those are our prototypes. I will now stop the screen share.
All right. Okay. Oh, thank you.